so that we have that. So that's recording now. And anyway, so yeah, project-based, maybe we can work on, have you working on that, that kind of thing. So any questions so far? No? You sure? Okay. So you do have a project due this week, Sunday night. And now I will go back to where I was, and I shouldn't have been. So module 1. And okay. So do that. Help me a bit. That's the big idea. Because we're doing a little in this article that okay, so sir, the home infection we'll have a couple things probably that have to do with the coronavirus, partly because what I try to do is find recent data, stuff that's going on right now. Well, pretty much in the news, that's what you hear. So that or the election, one of the two, take your pick. So since this class is more oriented toward nursing and biology and so forth, I thought the infection stuff made a little more sense. So, so we have, that one group felt that quality of rating mattered a lot as to whether a nursing home got higher levels of infection or lower levels of infection. And when you think about it, oh yeah, that might make sense. Higher rating. Well, maybe they're around patients more. Maybe it's cleaner. That's what gives it a higher rating. Better procedures on various things, more qualified staff, whatever that might mean for the particular nursing home. So it seems reasonable that a better quality nursing home might have lower infection rates. Okay? But then another study, and that's kind of what this one study was finding, Then another study, though, was finding that it had nothing to do with the quality of the nursing home. Nothing whatsoever. It had to do with what was happening in the community around it. You know, were there high infection levels in the community around the nursing home, or were they low? And as one might expect, oh, if they were higher, more stuff going on in the nursing homes, and if they were lower, less. And so what the idea of this project is to look at some data. Now, I made this data up because I could not get the data that were in these studies. And so I made some data up that had a particular type of answer. And don't read anything into, I think is what you'll find in this project is, yeah, quality rating had nothing to do with it. Well, in my data that I made up, okay? And I made it partly because that was the beginning of the article or the podcast or whatever, and partly because it just worked out easier that way. And so, so I'm not really saying, oh, well, obviously it was this answer versus that. I just have some data to show you that if you don't take confounding variables into account, you may get a wrong answer. And really, obviously, one of the two studies in some way must be wrong, because one says quality matters, the other one says it doesn't. They cannot both be right. Okay, so, and so what could have happened? And that's what this takes us through. Here's a section of data, the quality, and look at data and so forth. We've got some idea. They introduced and so forth, and right. So, it's right is what the data seem to be doing. Have to do with the quality of the nursing home on the x-axis and the infection level on the y-axis. And so it looks like the lower your quality, the higher the infection level. Great. Visual statistics right there. I mean, I can just look at it and go, yep, looks like something's probably going on along those lines. We'll learn, our quantitative techniques in later chapters, but visually it looks like, yep, that's probably what's going on. And looking at those things and get into looking at factoring in the regional effect and the regional infection level. And as one might expect, again, as well, I better do it over here with the mouse because Jordan can't see me pointing at the board. So, as you would expect, right, it's going up as the regional level of infection goes up, so does the nursing home level. Seems reasonable that might be true, and in this data set that happens. Okay, so now we talk about blocking, which is one of your vocabulary items in this first chapter. And when we block, so this particular one, we've got quality on the x-axis and regional infection level on the y-axis. And what we see is if we just look at those, now the regional infection level should have probably nothing to do with the quality of the nursing home. Maybe it could, and vice versa. But what it shows is that as the quality goes up, the infection level is going down. Okay, that's within the region. So this is saying, or by region, I guess. And so what we're seeing here is that there is a definite link there, even though I wouldn't think there is. There is. Right? As quality goes up, the regional infection level. Regional. So picture a nursing home in Louisville. Say Louisville's doing really badly in terms of infection level. But Louisville's also a really big city with much more money than we would have around here and so forth. So they could have a really top-notch quality nursing home. Well, but what this says is, well, even if they do, if the infection level there is really high, well, too bad. Or no, I guess the infection level might be low there, is what that's saying. But I can see a pattern, right? As quality goes up, the infection level goes down. So these two things that I wouldn't think have really much of anything to do with each other actually do in these data. Now, do they really, or is this a spurious correlation, as we would call it, or a spurious association? It does look like a straight line, so I could say correlation. It might be just happenstance, but there is a pattern there. Okay, it is heading down as we move to the right, and that possibly is the problem. Okay, so what happens is we down here, and what this stuff is doing is getting the data, the regional. So this is showing us pictures, which, actually, yeah. So here's the blocking idea, is that I still have quality down here on the x-axis. I have the nursing home infection level on the y-axis. That's that original picture. Remember that the original picture was heading down as I moved to the right. But the first one there is actually heading up as I move to the right. A little bit, not much. The first one's heading up. The middle one, it kind of goes up and then maybe down a little bit, or goes up and stays up, or something like that as far as the data. And the one on the right looks like it pretty much goes straight across. Okay, all of a sudden, the downward trend of as quality went up, the infection level went down. It's gone. Same data. Exact same data. It's just that what we did was we said, hey, if the regional infection level is low, let's plot all those together. And that's the left one. If the regional infection level is kind of in the middle, let's plot those all together. That's the middle one, and then the high is on the end. And when we do that, what we realize is if we account, and these are the words you hear in the news and so forth, if we account for the regional infection level, all of a sudden we see that quality isn't the key. Okay, it looked like it was when we first plotted it, but we didn't take this into account. It matters. Okay, so this first project, that's the whole idea, is it matters. Okay, confounding variables can matter. So there you go. Now, with this project, what happens, I have you do all these tasks. I go through, you learn to use spreadsheets, you learn to use some Desmos to do some things on, in different parts at times. You'll learn to use some of these technical things. Everybody should know how to use a spreadsheet if they graduate from college. I believe that. So, if you're not sure about spreadsheets, well, you'll get some practice in this class. But I'll answer whatever questions you have. And so you'll get some practice, technical practice with that. But then, the big key is at the end of this. Okay, so I push that key, hit enter. So what do you do? Write about it. Okay, so you're going to create your now report, and if you for a moment the whole is that it looks like an outline. Yeah, think of it that way. Okay, to fill everything out, and to think about what you need to put in and so forth. Because part of what I'm trying to do, you have a final project in this class. Many, many people over the years or over the semesters, a few years, have had a lot of trouble with the final project. Okay, so I am trying to combat that. And one of my things I'm doing is trying to get you all to think of these earlier projects the way students would in the past as well, but maybe they didn't, this is a model for how you might write up your final project, kinds of things to think about what you want to put in. And so follow this as an outline. Now, don't use the item numbers and so forth. In the directions, it does say somewhere, probably down here somewhere, maybe. Yeah, the very last line under flow and grammar, it reads, can I make it even a little bigger maybe? It reads, report for flow and grammar in bold must be important. Out the knowledge of description and instructions. Okay, so if you basically treat this like fill in the blank, that's not going to score very well on those points. Okay, because if the only way I understand what you put in there was because I wrote the guidelines to write up the project and all that, then those points are not going to be much. Okay, you need to treat it like you're telling your grandmother or something about it. I don't know why you would, but if you were, that's what you want to do. Okay. So that's the big picture of this first project. I don't know that I'll spend much time in future weeks, introducing the project, that kind of thing. Maybe I'll try to get some more videos. They take time, but I'll try to maybe make that happen to help with introducing the big ideas and so forth of the project itself. So we can talk about some of the other technical aspects of the course. Okay. Any questions so far? Anything on that? Did it scare you? Nah, they aren't too scary. The big thing is you want to pay attention to what I'm asking you to do and think about why, so that then by the time you get to that final project, you don't feel lost. And I think that's been sort of the problem in the past is, you know, I tell people, okay, do this, do this, do this, you know, write this up. And I didn't really force people to write it like they would their final project. That was, I think, my failing. And so people just didn't pay attention. And so then when they got to the final project, they didn't know what to do because they hadn't really paid attention to all the prior stuff that they were doing. Okay. All right. So let me switch to the text for a moment. And so we're going from 1.1 this week up through I think it's 1.5. I think that's right. Yeah. Text 1.5. Oh yeah, experiment. And so a big part of this is really just vocabulary. And so let me switch back to, if I'm able to do such a thing. There we go. Switch back to that. And, you know, so the big vocabulary. Variable types. I think that's relatively important. It helps us understand better what the heck we're doing with each of these tests. Because what's going to happen is once we hit chapter 3, we're going to essentially, you know, if I worked hard enough at it, I could probably find a data set that was fine for chapter 6, but then I could modify it to be fine for all the previous chapters. And that's really what's happening is once we hit chapter 3, for the most part, we're solving the same problem every module. Okay, it's not exactly the same. It's not said exactly the same way by any means. It's not the same variables. But the structure of the problem is exactly the same over and over again. Okay, so, you know, we introduce kind of the idea of what we're trying to do in chapters 1 and 2, but then in 3 through 6, we just keep solving that same basic problem. Okay, we do a few other things here and there, but what's different between the chapters is the variable types. Okay, and so we've got the basic one. You're pretty good with working with numerical stuff. That's, you know, we tend to use scatter plots when we have numerical variables, that kind of thing. For the most part, people do pretty well with the scatter plots. They're intuitive. I think you've seen enough of them over the years and all that. So numerical, what you want to sort of intuitively, what you want to think about with numerical is, you ask yourself this question, does it make sense to take an average? Okay, so does it make sense to take an average? Cody, are you seeing that okay?
Yep.
Great. You know, so when you think about things like, oh, you know, some of you want to do nursing, temperature. You need to take somebody's temperature, see if they're running a fever. Oh, a person's average body temperature? Oh yeah, average, that makes sense. All right, so where you take an average, that would tend to be a numerical variable. Now, numerical comes in two kinds. We have continuous. And again, that's a lot of stuff we tend to think about. So continuous, like a temperature, right? It could be 98, it could be 98.2, it could be 98.348, right? As many decimal places as we can measure with our equipment, you could get a temperature to that level. Okay, so continuous, no gaps in the numbers. Okay, theoretically, I mean, if I give you a sample of numbers, there will always be gaps. But theoretically, no gaps in the numbers. Something like that. It's a continuum. I can get any number, any set of decimals I might expect within whatever range makes sense, right? You don't have a negative temperature. And if you had a temperature of, 400, hopefully you're on the funeral pyre somewhere, something like that. But, so there's a range, but within that range, you don't think of gaps. Then we have discrete. And discrete, yep, there are gaps. So discrete, you could talk about a variable of number of floors of a building, right? Probably, in most cases, there aren't 3.2 floors on a building or in a building, right? There are 3 floors, there are 4 floors. Now, you can get into some fancy architectural things like split levels and that kind of thing. But generally speaking, right, you would say there's 1 floor, 2 floors, 3 floors, maybe a basement, maybe 2 basements or something. But you don't talk about the 1.35th floor. Discrete, but you could still talk about the building in number of floors, right? The building downtown is 2-story, or something like that. Or if you're in New York, maybe the average height of a building is 100 stories. Okay, so in that case, discrete. Now, it can get a little strange in here because you take something like age. Okay, right? Somebody's 18. They're 18 in a day. They're 18 in 2 days. They're 18 in some number of hours, right? Some partial, really small part of a year, or some number of seconds, right? Age is a funny one because it might be continuous. I mean, the way you treat it might be continuous, but you also might treat it as discrete. Somebody's either 18 or they're 19. You don't get to do the 18 and a half thing, That's what little kids are, I'm 5 and a half, or something like that. Or if they're really, really on top of their numbers, maybe they're even 5 3/4 or something like that, You might not want to do that, You might just say, well, we're 7-year-olds, 8-year-olds, 9-year-olds, but it could still make sense to talk about the average age. Okay, even though you're treating it as discrete. So some things can be up to us, but really what you want to do is think, okay, is it numerical? That's the big thing. And then maybe it's continuous or maybe it's discrete. Now, if it's not numerical, then it's categorical. the name says, things that tend to be yellow. Now I have noticed there's a lot more colors than what color is that? Blue. She says aqua. I don't know. All right. So, but they're still just categories. Right? Now one could get really sciencey and look at wavelengths of light and all that, and then all of a sudden you could turn them into something numerical. But for the most part, when we do studies, that kind of thing, if we're talking color, that's not the kind of study we're doing. We're wondering if the color of the walls enhances our educational experience. You know, does a light color or a dark color, right? So things like that. Okay, categories. It's really a name only. Okay, because why is this green? Well, because everybody tells me it's green. And we all seem to agree. Now, along those lines, I do not have good color vision. I'm not colorblind. I'm a little bit red-green colorblind, but not real colorblind. But on the other hand, I had a car that I told everybody it's gold, or bronze, I guess bronze, I would say. It wasn't really gold. But I looked at it and I said, that car is bronze. Everybody else who ever mentioned the color of that car said it was green. I don't know. Looked bronze to me. And, you know, so in that case, you know, it's just a name. You call it green, I call it bronze. I'm still driving the same car, right? Doesn't matter. So, but categories are name only, but you can get some weird things because, so name only, one case is nominal. Okay, and that literally means in name only. Okay, so if we have something that just, yeah, if, you know, think of a foreign language, and if I called it a different thing, if instead of red, I said what, rojo? Is that Spanish? Yeah. So I said rojo, you know, something like that. It's still red. I'm saying rojo, you know, or potato, potato. How about that one? Or tomato and tomato, that stuff we could start singing. You know, so it's really in name only. And so here, in a way, I'm not really saying anything that I'm not saying. You know, I mean, because that is the definition of that word, in name only. However, you can get things that are ordinal. Okay, there is an order. But it's not usually very well defined. Small, medium, large. Okay, if I went and looked at some shirts and I saw small, medium, large, I would expect if I laid them out, the small would be smaller than the large, and you know, and the medium would be in between. But yet, to talk about taking the average of small, medium, large, it doesn't really make sense. Okay? Because, well, what makes a small a small? Well, it's smaller than a medium. Well, but it's bigger than an extra small. Right? You know, so where do you draw the line? What does it mean? You know, if I had 4 mediums and a large, what's the average of that? Right? You know, it doesn't make sense. Or yet a better example, I think, would be postal address. Right? Or room numbers. What's the average room number? Who cares, right? It doesn't matter. And yet they're in order, right? If you know, so I know that if the number starts with 1, unless you're over in, what's the dorm, Phillips? Is that the one over by the library? You know? Yeah. So unless you're in that dorm, numbers usually make sense in buildings. Okay, so, you know, ordinal would be that case that, you know, if I saw, oh, the room number, like this room number is 118, my office 117, I figure it's on this first floor. If I see a number that's 324, I figure it's on the 3rd floor, right? There is some order to it. There, you know, it makes sense. And if somebody were to say, oh, you're on the 3rd floor, oh, you're probably, you know, or your number, your office number is 327, well, you're probably higher up in elevation than a person with their office number in the same building anyway, you know, 112. Yeah, probably, right? Usually they work that way. You go up a higher number, it's a higher floor. And so there's an order, but in the end, we could have just arbitrarily changed it, right? We could have done all buildings where the top floor was floor 1, the next floor down was floor 2, you know, because if you're on the top floor, you know, it's like, hey, number 1, number 1. So see, it would make sense. Go with top floor is number 1. You know, again, it doesn't matter, right? Not really. Not like numbers matter as far as, hey, 3 is 3 times as big as 1. 3 is 2 units bigger than 1. Right? It's a positive number. It's not a negative number. You know, those things, you can compare real live numbers. But when they're just these ordinal categories, you know, you can say, well, they do go in an order, but the relative size is not necessarily the right, you know, going to work out the right way. You know, small, medium, large, I don't know, you know, is a large twice as big as a small? Well, I don't know, maybe. Maybe in certain items of clothing or in toasters. I don't know, maybe a small toaster is for like little pieces of bread or something. I don't know. But as we it matters. Differently when we questions. That we really want there. Types of studies and observational. Versus experiment. And pretty much when you think of observational, now this is kind of a weird, I'm not sure this is the best way to look at it, but you're stuck with the data. So even if I give you a survey to fill out, now I maybe came up with the survey, but I'm kind of not really in charge of the data. I'm stuck with whatever you all put on the survey. Okay? Or if I go find somebody else's study, even if what they had done is an experiment, well, I'm stuck with their data. I'm looking at it as an observational study. Okay? Now, an experiment, the best way to think of that is you insert yourself. Now, You specifically, no, it's more metaphorical. You insert yourself. But, you know, so I might use a survey as part of an experiment, but say as an experiment, I'm trying to figure out, you know, how you all respond to me having a mask on, right? Well, you know, what might I do? Well, I might give you a survey about, you know, how do you feel in the classroom? Do you think there's learning going on? You know, those kinds of things. That's a survey. But the way I insert myself into the experiment is I get different masks. And I try different masks out. I might try different lighting or something like that along with the mask. You know, so I could insert myself by changing up your environment, okay, or a plant's environment or something else, okay. But in an experiment, you are inserting yourself as the scientist somehow in there and changing what goes on. You know, that one group sees something different than another group. And again, that's a bit metaphorical because you could be talking about rocks. Okay, but one group of rocks is treated differently somehow than another group. Okay, well, and I think that's about our time. You say, oh, thank goodness. Any questions at this point on anything? Due dates, anything like that? Clear as a bell. Yes, sir, Connor.
The reading assignment, we just have to go, you know, step by step.
Oh, the project?
No, not the project itself. The reading assignment.
Oh, okay, the writing part of the project. Yes, yes, the deliverable, what you have to turn in. Yeah, pretty much. If you go through the task to get all the information and kind of see what's going on, and then you follow that outline, but remember, don't just, you know, it says, I don't know, an introduction that has this, don't just write introduction and then 1.1 and, you know, and write something 2.1 and write something, you know, or something like that. Write it like a real life communicative paper and all that. But if you follow that outline, one, you will have all the items in there, so that's good. There was like 16 points right there. You have all the and you write it in a nice flow and so forth. Then probably you'll get your 10 points from the grammar and flow and all that. And then your other 24 points, you know, they come from actually writing something reasonable, but in a lot of ways, in these first few, I really kind of tell you what to write, you know, what the big point is for each of those things in many cases. And so if you make sure you mention the assumptions that are asked for and you know, mention the conclusions that came from the data and so forth, that's the rest of the rubric. Following that outline, you'll probably do it. Okay, and in the past, typically students start out on the first couple, 2-3 projects. I would say historically, so this is a data-oriented class. Historically, students have done very well. You know, like the first 3 projects, I don't know, 85% average, 90% average, or something like that. You know, quite well for a whole class. And but then they taper off. And partly I have felt it's probably partly because, well, the semester's wearing on, people are getting tired, and so that's part of it. I think part of it is I don't lead you as much toward the last projects. Well, so you got to think for yourself, and it's not that bad. You know, plenty of people have gotten nearly 100% on every project through the whole semester. And, it's not like they walked into the class going, oh yeah, I'm going to ace this because I know everything. And, no, they maybe walked into the class thinking they were going to fail in a couple of cases. And they did fine on stuff because they paid attention, they followed directions, they did what they were asked. And so yeah, certainly starting out, kind of follow what's asked for, but pay attention. It's kind of like I knew a person once that was described as having been around the block a few times but didn't pay attention. So, just pay attention to what you're doing and filling out. Don't just make it an exercise of trying to fill in some words that you think will get a good grade. Actually think about what you're doing. Anything else? No? Cody, anything? We have to wait, maybe he's fallen asleep or something. No, I'll take that as a no. So, all right. I will, I guess, see you next Tuesday. But don't be a stranger on the internet or anything like that. Let me know if you have any questions about anything.